Okay, so I'm gonna... Oh, I thought it was 4. I'm getting it. I said that's too close. It's just one for that. Now, ABC for my moment. Okay, so 5 joined. No, I'm not opening it. Wait, Well, I'm not wishing this out. Haha. Haha. You're so dumb. Not real. Oh, is that Nikola Tesla? Oh, Just die already. Haha. We're coming back. He already left. I look up and all around you there is only this endless expanse of rock, all the same until the horizon, a desolate desert landscape. Oh yeah, I forgot. I'm Google. I give him a nod that means always well, but inside I am afraid. I become aware of this situation. Me standing on the surface of another planet, a killer planet at that. The viewer tells me I've been out for 4 minutes, and turn around and leave me there. I step into the chamber and I already know I'm going to miss you in a minute. I'm going to miss you for the rest of my life. Come on, let's get out of here, Don. How will we journey to Mars? Mars. It's all everyone can talk about recently. Humans do always have a deep desire to explore and seek adventure. From our youngest to our eldest. And when they set their minds to something, they become unstoppable. Some have traveled across continents, flown ships, flown airplanes, and even launched rockets to discover new lands and push the boundaries of what's possible. And until now, no challenge has been too impossible to overcome. But there's one adventure that we haven't fully tackled yet, and it's a big one. It follows a crew of characters in a futuristic world where humans have colonized from Earth to Mars to the asteroid belt. They explore new worlds, uncover conspiracies, and fight for survival in a universe full of danger. And while we're not quite at the level of interplanetary travel just yet, a thrilling glimpse into what the future of space exploration could look like gives us the motivation to keep going. Can you imagine building territory and expanding to Mars? It would be incredible to be part of that journey and make history. Who knows what we might discover on our way to the 4th planet from the sun? Let's see together what this trip would look like. Previous missions. So what have we sent so far to Mars? Mars is an interesting world that is covered in dust and has a very thin atmosphere. Despite its harsh conditions, Mars is a dynamic planet that experiences seasons, has polar ice caps, and features canyons and extinct volcanoes, all of which we are a little familiar with on Earth. Scientists have even found evidence that Mars was even more attractive in the past, which is exciting to explore and actually makes it the most explored planet so far. We sent a few different types of robotic explorers to Mars in order to learn more about it. The most advanced of these robots is called Perseverance, which just landed on Mars in February 2021. It's the largest rover ever sent to another planet and has the ability to take samples of the alien soil and rocks. There's also a helicopter named Ingenuity that came along with Perseverance. Perseverance isn't the only spacecraft currently on Mars. extensive planning and preparation before deployment. The return trip is then only 210 days, which is shortened thanks to an ideal transfer window. Of course, the current technology we have limits our abilities to make these journeys faster and smoother. However, NASA is always working on improving propulsion systems and technology, so we may see faster and more comfortable trips to Mars in the future. Future space trips. NASA and DARPA are teaming up to create a super cool spacecraft that will be powered by a nuclear thermal rocket engine. It's called the Demonstration Rocket for Agile Cislunar Operations. This spacecraft will be able to travel faster, carry more stuff, and further distances, and maneuver through space much more easily than any other vehicle we've ever used before. One major benefit of this new engine is that it will increase science payload capacity and provide in July 1995 and on December 7th, 1995. The two ships reached the gas giant together. The mother probe entered into an orbit around the planet, while the little one penetrated its atmosphere at a speed of 48 kilometers per second. After which, in little more than 2 minutes, it was slowed down to 'Nothing prevents us from putting together what little we know with a bit of imagination and fantasize about what we might see as we descend towards the core. Obviously protected by a super pressurized suit. A dive that will allow us to discover the secrets of one of the most extreme environments of the solar system. Are you ready? En route to Jupiter. We are 500,000 kilometers away from Jupiter, aboard our ship, and the approach phase is much longer than expected. We are navigating at maximum speed allowed by our propulsion system, yet it seems that the planet is not approaching 1 meter. The outermost layers of its atmosphere begin to occupy the entire field of view only after several hours of travel, when we are still 200,000 kilometers away from the apparent surface of the planet, that is, from the top of its highest cloud. Now the entire disk of the planet extends into the sky for about 40 degrees of apparent diameter. Finally, we see in detail the dense clouds of ammonia and hydrogen that rotate in parallel around the equator, forming the characteristic white, red, and orange bands. Jupiter, as well as the Sun and Saturn, is in fact subject to a differential rotation phenomenon. Because of its high-speed rotation, 9.9 hours, the gases that make up the upper layers of the atmosphere, namely hydrogen, helium, and ammonia, move at different speeds depending on their position with respect to the equator, creating the characteristic horizontal bands of different color. Usually the red ones, called zones, correspond to atmospheric depressions caused by descending cold air, while the lighter ones, the bands, are cloudy reliefs formed by rising hot air. The Great Red Spot, so clean and geometric if seen from a distance, slowly begins to transform. So Jupiter resemble a huge pot full of bubbling water. Arrived at 100,000 kilometers from the surface, the electromagnetic bombardment caused by the Jovian magnetosphere is so intense that we are forced to activate the special protections of our ship. If we did not, we would die of radiation poisoning in minutes. Jupiter is in fact like a giant dynamo. Because of its fast rotation period, the speed with which the hydrogen slides on the inner core of the planet generates strong electric currents that give rise to a magnetosphere 20,000 times more powerful than the Earth. The magnetosphere then traps solar emissions in huge bands of radiation, generating a radioactive environment that is a deadly risk both for probes, whose instrumentation must be adequately shielded, and for astronauts. 0 kilometers, the descent begins. Continuing our journey, we finally reach the edge of the troposphere, the zero limit at which we begin to descent, as we would do with the depth of an oceanic trench. The long descent to the innermost layers of the gas giant begins here. We disengage from the spacecraft, protected by our magical spacesuit, and let gravity drag us towards the core. Because of its enormous mass, at this height, Jupiter generates a gravitational acceleration 2.6 times higher than the Earth. So if we want to avoid burning like a meteor, we have to open a parachute to slow the fall. We do it, and in a few minutes, our speed goes from 7,200 to 360 kilometers per hour. -10 could do it, we would see a spectacle without equal. The cloud that surrounds us is the we would immediately notice that ammonia covers the upper surface of the clouds like an oil film on water, adding a hue of white to the dominant red color. Pushing our eyes even further in the direction of the Great Red Spot, we would see a huge column of turbulent gas soaring over the surrounding clouds, almost as if it were floating above the troposphere. Minus 50 kilometers, lightning and turbulence. At the height at which we are now, about minus 50 kilometers from the beginning of the troposphere, the conditions of pressure and temperature are similar to those detectable on the surface of the Earth. But the winds raging around us are dragging us at speeds of over 560 kilometers per hour, and the intensity of radiation generated by the Jovian magnetic field could still kill us in a few minutes in the absence of protection. The noise generated by the turbulence is deafening because here the speed of sound is 4 times higher than we are used to. The sound is continuously crossed by violent lightning tens of kilometers long, thousands of times more powerful than those generated on Earth. The lightning is mainly caused by rains of water, sulfuric acid, and ammonia, which due to the gravitational attraction Another 25 minutes pass, and the situation begins to complicate. Special protective suit must withstand a temperature above 100 degrees Celsius, increasing, accompanied by enough atmospheric pressure to crumple a car. We find ourselves suddenly immersed in darkness, and we can no longer distinguish anything. The absence of light is due to the density and chemical composition of air. Around us now, there are only nitrogen, helium, ammonium sulfide, and traces of water vapor compressed to the point of absorbing all the electromagnetic radiation coming from the sun. Our journey has turned into a slow fall into darkness. Minus 20,000 kilometers. Gas has become liquid. We continue to slow down due to the increasing atmospheric density, while incandescent helium is raining around us. The gases compress more and more, starting to behave like liquids. If we had to leave our protective suit, we would be crushed and vaporized in a split second. Now we are no longer even able to determine where we are in relation to Jupiter's core, because the transition between gas and liquid is so gradual that we cannot realize the change in density. Below us, at an unspecified distance, we notice a faint luminescence caused by the energy radiating from the nucleus. Atmosphere is now almost completely formed by liquid hydrogen that boils at thousands of degrees centigrade. As on the surface of the sun, the pressure rises rapidly from 1,000 to 2 million bar, and the atmospheric density has exceeded the water density by a while, reaching even 1,000 kilograms per cubic centimeter. At this point, the fall stops, because our body being less than the matter around it, can no longer sink.
Wow!
If we want to continue, we need a push. So we turn on the propellers of the suit and start to descend slowly again. Minus 30,000 kilometers. An ocean of liquid metal. From here on, and for several hours, the journey is particularly boring. Darkness and silence dominate, and the monotony is interrupted only by the imperceptible flashes that emanate from the deepest regions of the planet. Continuing on becomes more and more difficult. After a time that seems endless, however, something unexpected happens. The darkness is torn by a web of lightning that vaguely resembles a spider's web. This network of lightning branches out following a very particular geometry, which closely resembles the way electricity propagates in the water. We are sailing in a vast ocean of metallic liquid hydrogen. Under normal conditions of pressure and temperature, hydrogen is a gas. But if its density exceeds a certain critical point, it turns into something different. A substance that flows like a viscous liquid and conducts electricity like a metal. The lightning we saw in the troposphere are nothing compared to those that cross this boundless ocean. Where we are now, pressure and temperature have reached such high levels that the escaping we can't yet understand. Minus 60,000 kilometers, the core. No matter how hard we try, we can't go any further. Solid and contains most of the heaviest elements of the planet, such as ice, rock, iron, and other heavy components, with a considerable amount of hydrogen. To be able to walk on its surface, we should be able to survive pressures 4 million times higher than the Earth's surface, and temperatures of over 35,000 degrees. A bit too much even for our imagination. After all, it is only thanks to the latter that we can bear the idea of being forced to stay here forever. A realm from which no means of propulsion, no matter how powerful, would ever be able to pull us out. These observations were most likely made by a Assyrian astronomer around the 14th century BC, who communicated used to designate Mercury in the Mayan tablets is translated as the jumping planet. Babylonian records of Mercury date back to the first millennium BC. The Babylonians called the planet Nabu, after the messenger to the gods in their mythology, which is ironic because Mercury is the name of the messenger god to the Roman pantheon. Many other civilizations found out about Mercury in their own ways, including the ancient Greeks, Roman, Chinese, and even the Maya. The first telescopic observations of Mercury were made by Galileo in the early 17th century, although he observed phases when he looked at Venus. His telescope was not powerful enough to see the phases of Mercury. In 1631, Argus made the first telescopic observations of the transit of a planet across the sun, when he saw a transit of Mercury predicted by Johannes Kepler. In 1639, Giovanni Zucchi used a telescope to discover that the planet had orbital phases similar to Venus and the Moon. The observation demonstrated conclusively that Mercury orbited around the sun. In the 1880s, Giovanni Schiaparelli mapped the planet more accurately and even perfectly detailed its orbital time around the sun. As more time went on, more time was devoted to studying Mercury, including in the 1970s when NASA launched the first craft to Mercury via the Mariner 10. The Messenger and the Bepi Colombo would later follow in its footsteps. For the record, the Bepi Colombo is set to reach Mercury in 2025. Though there is still a lot we don't know about Mercury, we do know a lot based on probes and pictures and studies that have carried us over through the ocean ocean. Which is why Mercury, like other planets, is really is indeed the closest planet to the Sun. Because of this, it has certain perks, as well as disadvantages. First and foremost, it's the closest planet to the Sun, and the second hottest planet in the solar system after Venus. It's only 29 million miles from the Sun at its closest. Now, yes, I'm sure this seems like a long distance, but when you're talking about the Sun, which is elliptical in nature for the record. And as for how long a day is, well, that's where the twist comes in. Because you see, a day is the amount of time it takes for the planet to rotate around its axis. That's some real weird planet calendar, but that's just how Mercury is. Number 8. How hot does it get there? The surface temperature of Mercury ranges from 100 to 700 Kelvin, minus 173 to 427 degrees Celsius, minus 280 to 800 degrees Fahrenheit, at most extreme places. It never rises above 180 Kelvin at the poles, due to the absence of an atmosphere and a steep temperature gradient between the equator and the poles. The sun's solar point reaches about 700 Kelvin during perihelion, 0 degrees west or 180 degrees west, but only 550 Kelvin at aphelion. On the dark side of the planet, temperatures average 110 Kelvin. The intensity of sunlight on Mercury's surface ranges between 4.59 and 10.61 times the solar constant. Although the daylight temperature at the surface of Mercury is generally extremely high, observations strongly suggest that ice, frozen water, exists on Mercury. The floors of deep craters at the poles are never exposed to direct sunlight, and temperatures there remain below 102 Kelvin, far lower than the global average. Water ice strongly reflects radar, and observations by the 70-meter Goldstone Solar System radar and the VLA in the early 1990s revealed that there are patches of high radar reflection near the poles. Although ice was not the only possible cause of these reflective regions, astronomers think it was the most likely. Regardless of that, though, these extreme temperatures are why Mercury is such a different planet compared to the rest of the solar system. Number 7. The atmosphere. When thinking about a planet, one of the most considered things is the atmosphere, because through that we get a look at how the surface is affected and how life might be able to survive there. Mercury is too small and hot for its gravity to retain any significant atmosphere over long periods of time. It does have a tenuous surface-bound exosphere containing hydrogen, helium, oxygen, sodium, calcium, potassium, and others, and a surface pressure of less than approximately 0.5 mpm, 0.005 picobars. This exosphere is not stable. Atoms are continuously lost and replenished from a variety of sources. Hydrogen atoms and helium atoms probably come from the solar wind diffusing into Mercury's magnetosphere before later escaping back into space. Radioactive decay elements within Mercury's crust is another source of helium, as well as sodium and potassium. Now, all of that being said, Mercury has a significant and apparently glowing magnetic field. According to measurements taken by Mariner 10, it is about 1.1% the strength of Earth's. The magnetic field strength at Mercury's equator is about 300 MT. Like that of Earth, Mercury's magnetic field is dipolar. And like Earth's, Mercury's poles are nearly aligned with the planet's spin axis. Measurements from both the Mariner 10 and the Messenger space probes have indicated that the strength and shape of the magnetic field are stable. It is likely that this magnetic field is generated by a dynamo effect, in a manner similar to the magnetic field of Earth. This dynamo effect would result from the circulation of the planet's iron-rich liquid core. Particularly strong tidal effects caused by the planet's high orbital eccentricity would serve to keep the core in the liquid state necessary for this dynamo effect. Number 6. Life on Mercury? Given some of the things we just talked about, I'm sure it's weird for some of you that many think that there could have been life on Mercury at one point in time. And yet it's true. There may be scientific support based on studies reported in March of 2020 for considering that parts of the planet Mercury may have been habitable and perhaps that life forms, albeit likely primitive, microorganisms, may have existed on the planet. The theories are help to remember pure may have existed in parts of the planet Mercury, because while it is a planet that has a very rough surface and very fluctuating temperatures, it's also a planet that is surprising in how it has both ice and water vapor. And water is a key basis for life anywhere, including on Earth and on Mercury. Granted, no actual proof has been found that life was on Mercury, or when it was there and when it apparently died out. But if there is even a small chance that it was there at one point, you can bet that people are going to look into it. Because if something can live on Mercury, even in the smallest of forms, it gives many hope for life on many other planets in the universe. Number 5. Mercury is big in pop culture. The smallest planet in our solar system has a big presence in our collective imagination, which is a bit interesting considering how much more popular the other planets are compared to Mercury. Scores of science fiction writers have been inspired by Mercury, including Isaac Asimov, C.S. Lewis, Ray Bradbury, Arthur C. Clarke, and H.P. Lovecraft. Television and film writers too have found the planet an ideal location for storytelling. In the animated television show Invader Zim, Mercury is turned into a prototype giant spaceship by the extinct Martians. And in the 2007 film Sunshine, the Icarus II spacecraft goes into orbit around Mercury to rendezvous with the Icarus I. In the comic strip Calvin and Hobbes, Calvin and his classmate Susie give a presentation about Mercury, in which Calvin's contribution is full of questionable information. The planet Mercury was named after a Roman god with winged feet, says Calvin. Mercury was the god of flowers and bouquets, which is why today he is a registered trademark of FTG Florists. Why they named the planet after this guy, I can't imagine. Despite Calvin's analysis, Mercury has been used even more than that, which goes to show that when it comes to storytelling, just about any planet is a viable option for something. Number 4. Natural disasters. Here's something you may not know. Because of its proximity to the sun and the lack of a true atmosphere, Mercury has no seasons, not a single one, which you would think would mean that Mercury doesn't have any natural disasters happen to it like they are on Earth. But that is only half true. Yes, in regards to things like rainstorms or tornadoes or hurricanes, Mercury will never have to worry about those at all. However, in regards to earthquakes, it is believed to have them, but not in the way you're thinking. Earth has earthquakes because of tectonic activity, but in regards to Mercury, it likely has earthquakes because the sun is quite literally shrinking the planet via its gravitational pull. What's more, because of the protective atmosphere and a weaker magnetosphere than what Earth has, Mercury is subjected to many different impacts from asteroids and meteors. Number 3. No moons or rings. It may seem rather obvious to indicate that Mercury has no moon or no rings. But what makes that such an important fact is that it's one of the few planets in our solar system that doesn't have a moon. Think about it. How many planets in our solar system don't have a moon? The answer is 2. Mercury and Venus. The reason they don't have a moon is honestly very simple. Because of how close they are to the sun, the gravitational pull of the sun is much greater than the planets. Thus, if any entity tried to make itself the moon of one of these planets, the sun's inertia would pull it away. This is the same reason they don't have rings, as any debris would be plucked away by the sun. Number 2. Gravity. Another major thing that is thought about when it comes to planets we might colonize is gravity. How much gravity a planet exerts will drastically affect its inhabitants and the planet itself. In the case of Mercury, the planet is one that has gravity 62% less than that of Earth, which means that if you weighed 100 pounds on Earth and somehow got to Mercury, your body weight, not including the spacesuit of course, would equal just 38 pounds. That means that you would be able to go and jump very high on the surface of the planet. It also means that because of the reduced gravity, you would have to work very hard in order to ensure that your bones don't become brittle and weak due to the lesser forces exerted on it. Number one, could we live on Mercury? One of humanity's greatest things is the ability to think about possibilities. And when it comes to space, the possibility that everyone talks about is being able to live on other planets. Most agree that Mars is going to be the first planet we colonize. But what about Mercury? Could we live there? Technically speaking, we could, if we had the right amount of technology. It would be possible to shield ourselves from the sun and massively fluctuating temperature, which would be one of the biggest initial hurdles for colonizing there. However, the disadvantages of trying to live there far outweigh any pluses. True, we would have almost unlimited solar power. As noted earlier, a planet that is only two-fifths the size of Earth, with slightly lost rotation, the supreme lack of gravity, soil that very likely won't support growth of crops and more, we have an even harder time colonizing Mercury than we would colonizing Mars. And colonizing Mars is going to be quite an endeavor. Could it be possible one day to colonize Mercury? Absolutely. With the right technology, anything is possible. But will we colonize Mercury? That's another story. Number 8. The history of Venus. Before we get into the facts and figures and the numbers behind the planet that is Venus, we probably should talk about how we discovered it. After all, astronomy has been going on for a very long time, and people have found planets like Venus before you would expect them to. In the old Babylonian period, the planet Venus was known as Nintiana, and later as Dilmun. The name Nintiana translates to divine illumination of heaven, which refers to Venus as the brightest visible star. The ancient Greeks initially believed Venus to be two separate stars, Bosphorus, the morning star, and Hesperus, the evening star. Pliny the Elder credited the realization of the singular of their traditional Greek names. When the Italian physicist Galileo Galilei first observed the planet in the early 17th century, he found it showed phases like the moon, varying from crescent to gibbous to full and pulsing. When Venus is furthest from the sun in the sky, it shows a half-lit phase. And when it is closest to the sun in the sky, it shows a crescent or phase. This could be possible only if Venus orbited the sun. And this was another observations that clearly contradict the Ptolemaic geocentric model that the solar system was concentric and centered on Earth, which was one of many theories about how our world and our universe were at the center of it all, when in fact that couldn't be farther from the truth. The atmosphere of Venus was discovered in 1761 by Russian polymath Mikhail Lomonosov. Venus's atmosphere was observed in 1790 by German astronomer Johann Schroeder. Schroeder found when the planet was a thin crescent, the test extended 200 sunlight in the tangential sphere. Later, American astronomer Justice Smith Lyman observed a complete ring around the bright side of the planet, and it was at interior conjunction, providing further evidence for an atmosphere. Believe it or not, we're looking at taking life and visitors when more details and research is done on Venus. One of the really wants to live on.